Let's start the class with some observational skills. So let's start with some squares. 50 square is 2500, which you very well know. Now, do you know what is 51 square? Okay, that is 2601. Now, try to establish a pattern. If I tell you 52 square is 2704, can you see a pattern developing? Right. Okay, now try 53 square. Yeah, it will be 2809. Right, like in 53 square, how far is 53 from 50? 3 units. So 25 plus 3 and 3 square, which is 09. So 54 square will be 29 and 4 square, which is 16. 55 square, yeah, 25 plus 5, 30 and 5 square, which is 25. 56 square is 3136. 57 square, 3249. Similarly, 58 square will be 25 plus 8, 33, followed by 8 square, which is 64. 59 square will be 3, 4, and square of 9, 81. And 60 square is 3600.
If we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
Isn't it interesting? There are patterns everywhere. No wonder mathematics is called as a language of the cosmos. Hi everyone, this is Shilpa, and in today's video, we will be doing squaring of any natural number mentally without writing any steps. If you're wondering what is Vedic mathematics, please go through my previous video. In this video, I have explained in detail what is Vedic mathematics, how is it relevant in today's digital world. Before we delve in today's class, which is on squaring of any natural number, let's just address some few questions and also the do's and don'ts. Let's start with the first question. Is Vedic mathematics relevant to entrance exam preparation? Yes, of course, Vedic mathematics is relevant for the entrance exam where the students are pitted against other students and time becomes a crucial factor because, of course, this is a faster way of doing calculations. But it is not only relevant to the entrance exam students, it is also relevant for any school student or for anyone who wants to do mental calculations, who doesn't want to be dependent on any gadgets to get an answer. Calculation technique using Vedic mathematics also has other benefits. It removes the anxiety of questions involving heavy calculations. In a way, you become more confident of the question when you're not scared of the calculations. You're faster in calculation with this technique. It is easier to manage time because of the mental calculations. It gives you the flexibility in deciding the level of questions if it is easy or hard. Instead of depending on the calculator, finding the data, you get your answer instantly. Mental calculations helps in improving confidence and concentration. Before we go in depth into solving the square of any natural number, please make sure that you try to do it mentally. Try not to use pen paper. And again, when we are doing mental calculation, our brain is much equipped to do calculations from left to right. For example, 50 square was 2500. 51 square is 2601. So 52 square is 2704. So left to right approach, we are much faster. However, when we write on the paper, we start from the decimal end. So let's have fun. So let's reiterate the pointers which you need to remember. Try avoiding using pen and paper. Remember, approximation is way better than perfection. So speed is more important over here compared to accuracy. So as I said, follow left to right approach while solving it mentally. It's perfectly okay to make mistakes. Be creative, and flexibility is really important. If you figure some different way of solving, please explore. So let's see some pattern. 25 square is 2 into 3 followed by 25. Now it's easy to remember 25 square, right? 625. So what is 35 square? Of course, 3 into 4 followed by 25, right? So 45 square, 4 into 5, which is 20, 25. So if I ask you 55 square, you would know your answer is 5 6 are 30 followed by 25. So 65 square will be 4225. 75 square will be 5625. I hope you remember the multiplication tables. So 85 square would be 8 9s are 72 followed by 25. So you can see squares of any number which is ending in 5 will always end in 25. And the number of tens, for example, 95 square, your answer is 9 into 10 followed by 25. Now you might wonder, is it limited to only 2-digit numbers ending in 5? No. So if I have 105, here I'll take 10, right? So 10 into 11 followed by 25. So here we are talking about the number of tens, not the 10th digit. So if I have 115 square, it is 11 into 12 followed by 25. Yes, even if it is a 4-digit number, 5-digit number, any number ending in 5, right? So for example, if it is 1005 square, it is 100 into 101 followed by 25. So you can generalize this method, that is square of any numbers ending in 5 as, so n, where n is the number of tens. So n into n plus 1 followed by 25. So when we had 1005 square, n is 100. So 100 into 101 followed by 25. So let's move on to other patterns. This is just miscellaneous patterns. Now, if I ask you 11 square, of course you know 121, right? Or you can see the pattern 11 plus 1, 12 followed by 1. So 12 square will be 12 plus 2 followed by 2 square. So that is 144. 13 square, 13 plus 3 followed by 3 square, which is 169. So 14 square will be 14 plus 4, which is 18 followed by 4 square. Now 4 square is 16, so 1 goes as a carry forward. So your answer is 18 plus 1, 19 followed by 6. So if I ask you 15 square, it is 15 plus 5 followed by 5 square. And 5 square will give you a carry forward of 2. So your answer is 15 plus 5, 20 plus 2. So 22 followed by 5. 16 square is 16 plus 6, which is 22. And 66 square gives you a carry forward of 3. So 22 plus 3, 25 followed by 6. Before we talk about the two different methods for squaring any numbers, let's understand what do you mean by squares. A square is a number which gets multiplied by itself, right? So its x square is x into x. So you can see why do we call it as a square? A number multiplied along the length and along the width. Let's dig deep into the squaring methods. So we will be discussing universal method and base method. So let's start with the universal method of squaring. As the term suggests, it is applicable for any squaring. There is no constraint to this method. Now, I hope all of you remember what is a plus b the whole square, right? So it is a square plus 2ab plus b square. Now, if you remember this formula, I'm just going to remove that spaces. So for squaring any number of the form ab square, I'm going to write in the form a square followed by 2ab followed by b square. Now, this is a partition, okay? This will be the partition. So any two-digit number square, if we want to do the square. Now you'll be questioning me, what is A and what is B? So A is the number of tens and B is your unit digit. And also remember, after the partition, you have only one space. So if you come across a two-digit number, for example, 16, you will write 6 and 1 goes carry forward to the neighbor. So again, 2AB, you get a 2-digit number. You will only write the single digit. Anything extra goes carry forward to the neighbor. So let's see some examples. So 41 square. So 41 square as per your AB square form is your A square followed by 2AB followed by B square. So 1 square is 1. And what is 4 into 2? 8. So your answer will be 1681. Okay. Now let's try another number, 32 square. So if you see 32 square, 3 square followed by 3 into 2 into 2 followed by 2 square, which is again A square, 2AB, B square. So 3 2s are 6, 6 2s are 12. So 2 square you get the answer as 4, but over here you get the answer as 12. So you will write 2 and 1 as carry forward. You will write 2 and 1 as carry forward. So 3 square is 9. 9 plus 1 gives you 10. So try some more questions. 72 square. So 72 square will be 7 square, 2 into 7 into 2 followed by 2 square. So 2 square will give you 4. 7 into 2, 14. 14 double 28. You will write 8. 2 is carry forward, which gets added to the neighbor. So 7 square is 49. 49 plus 2. Your answer is 5184. 58 square. 5 square, 2 into 5 into 8 followed by 8 square. Now remember, you get 8 square, which is 64. So you write 4 and 6 is carry forward. 8 into 5, 40. 40 into 2 is 80. 80 plus 6, 86. You will write 6 and 8 is carry forward. 5 square is 25. So 25 plus 8. And you get your answer as 3364. So remember the carry forward. You are only allowed to write unit digit. Everything else goes to the neighbor. Now you would be curious, is it applicable only for 2-digit numbers? What if I get a 3-digit number or a 4-digit number? So the method is called universal method, which means it is applicable for squaring of any digit numbers. So let's try a 3-digit number, 123 square. So remember I said A is the number of tens and B is your unit digit. So same, A square followed by 2AB followed by B square. So 3 square gives you 9. 12 3s are 36. 36 double gives you 72. You will write 2 and 7 goes carry forward. So 12 square is 144. 144 plus 7. So you get your answer as 15129. Let's try one more. How about 1002 square? So here your A is 100 and B is 2. So A square, 2AB followed by B square. So 2 square is 4. 100 into 4, 400. Are you allowed to write 400? Of course not. You will write 0 and 40 goes carry forward. And what is 100 square? 100 into 100. So 4 zeros. So you get 100404. Perfect. Moving on to the base method of squaring. Now let's start with the patterns. So if I ask you 103 square, that is 106 followed by 09. 104 square would be 108 followed by 16. 105 square is 11025. 106 square will be 11236. 107 square is 11449. 108 square is 116 followed by 64. 109 square, 118 followed by 81. And if I move on to 111 square, now here when we say 11 square, there is 121 and you're only allowed to write 2 digits. So 1 goes carry forward. So 11 2s are 22. So 122 plus 1. So 112 square will be 124. Will have a carry forward of 144. So you have 12544. 113 square will be, remember 13 square 169, the 1 gets carried forward. So instead of 126, you will have 127 followed by 69. 114 square is 12996. Now let's generalize this as a formula. So we can see what we are doing over here is B is a base, like in this case 100 was a base plus twice of surplus. X is a surplus, it can be a deficit also. Now this is a partition. So after the partition, it's x square. So remember, the number of digits after the partition is equal to the number of zeros in base. So if your base is 100, you have 2 digits after the partition. If your base is 1000, you have 3 digits after the partition. Let's see some example. 106 square, the base is 100, 100 plus 2 into 6 followed by 6 square. Since 100 is the base, you have 2 places after the decimal, you get the answer as 36. So 11236. So if you have 103 square, it is 106 followed by 09. Okay, you don't write 9, you write 09. What if I have 113 square? Now 13 square is 169, so you were allowed to write 69. 1 goes carry forward. So you get 12769. And if it is a base as 1000, so remember, after the partition, you will have 3 places. So 1000 plus 2 into 13 followed by 169. Easy? Now, X is a surplus or deficit. Now, let's understand what you mean by deficit here. So let's see patterns. 99 square is 9801. 98 square is 9604. Are you getting that pattern over here? Now, can you predict what is 97 square? It will be 9409. What is 96 square? It will be 9216. What is 95 square? 9025. 96 square will be 88 followed by 6 square. 93 square will be 86 followed by 7 square. 92 square will be 84 followed by 8 square. 91 square will be 8281. 90 square? Yeah. So what if I ask you 89 square? Okay. So are you able to see the generalization? Let's put in formula and see. So the formula was b plus 2x followed by x square, where x is a deficit here, right? So in 98 square, your formula becomes 100 plus 2 into minus 2, which is 100 minus 4 gives you 96, followed by minus 2 square is 04. So if I have 94 square, 100 plus 2 into minus 6, which is 100 minus 12, that's how you get that 88, and minus 6 square is 36. Remember, the same rule applies. The number of digits after partition is equal to the number of zeros in the base. So if you have a 999 square, the base is 1000. So 1000 plus 2 into minus 1, which is 1000 minus 2, 998, followed by minus 1 square. You don't write 1 here. Since it is 1000 as a base, you write it as 001. Try one more. 997 square, 1000 plus 2 into minus 3, which is 1000 minus 6, 994. And minus 3 square is written as 009. Now, you would be wondering, what about a number like 200, 300, 400? Does the base method still applies over here? Of course, it applies. Right? The formula can be generalized as n into b plus 2x followed by x square, where n is the leading digit of the base. Try this question and see if you're able to get. So here I have some examples. Give it. For example, 203 square. The base is 200, but the leading digit is 2. So your answer is 2 into 200 plus 2 into 3 followed by 3 square. And again, after the partition, the number of digits depends upon the number of zeros in the base. So 502 square is 5 into 500 plus 2 into 2 followed by 2 square. So you have 504 into 5, that gives you 2520 followed by 04. 4006 square, 4 into 4000 plus 2 into 6 followed by 6 square. Since it is 4003 zeros, you have 3 digits over here. So that's why you write 6 square as 036. So you have seen both the universal method of squaring as well as base method of squaring. The universal method of squaring is based on a simple generalization, which is AB square is equal to, just start with A square followed by 2AB followed by B square. One space for 2AB and one space for B square. And try to follow the left to right approach. So even if you have a big number like 72 square, right, you would start with 7 square, which is 4900. So you know your answer is like 49 followed by 2 places. Now you remember there's a carry forward which you get from 2AB. So 7 into 2, 14, 14 double, 28. So you write 8 and 2 goes carry forward. So 49 plus 2. So 5, 1, 8, 4. I know it will not be easy to do all of it in memory, but try to practice where you can remember more numbers in your mind. So let's try another question. So if I give you 123 square in the universal method, now you know A is 12 and B is 3. So you start with A square, which is 12 square, followed by 2 into 12 into 3, followed by 3 square. And 12 square is what? 144. So your answer would be like 144 followed by 2 places. So let's talk about the tens digit, which is 12 threes are 36, 36 double 72. So that 7 comes as a carry forward. So 144 plus 7. So 151, right? Followed by, we've already done that 72, so 2. So 151 followed by 2 and followed by 3 square, which is 9. Try practicing this method, it will help. Now, the base method is a observation-based method where we just observe and it's easier. Like for example, if I ask you what is 108 square, it's easier with the base method where you simply get 11664. 109 square, 118, 81. Even if I go higher and I ask you 112 square, you will start with 124 and then you say 12 square has a carry forward of 144. So that's why if I ask you 112 square, your answer is 12544. So if I ask you 1008 square, again with this method, there is no need even to blink your eye, you straight away get an answer. Now, one of the most common question which students ask is, when do I decide to use universal method and when do I use the base method? So universal method can be used without any constraint. Even if you are in confusion, you can use universal method. Now pattern method we will prefer when the number is closer to the base. So if I give you 153 square, I would not prefer the base method because 53 is very far from the base 100. So there I'll prefer the universal method. That's all for today's video. Thank you. And don't forget to subscribe.